Checking. Good morning, class. This is our first time through this, so it'll be a little bit shaky, but here's some information that I'd like to share with you at this time. I've tried to make this online experience as similar as possible to what was previously done in the classroom. At the advice of people much more tech savvy than I, we have chosen this particular method to give online lectures. This medium will allow me to continually show the PowerPoint slide and also give me the ability to speak and write directly below the slide, similar to what was previously written on the whiteboard. If you have questions, we will communicate via email. It will be important when you email me to clearly identify what lesson you are referring to and what slide you have a question on. This will prevent a lot of email tag and be more efficient for all. I have about 115 students, so this will be really important. There's a number of advantages to this medium versus what we did in class. The first advantage is that anytime you can pause this video or rewind it and run a portion or all of it over again. I would suggest getting familiar with how to do that. It's the bar at the bottom of the page once you see the video. At the end of the video, you will be given an assignment to complete. Take a good and readable picture on your phone of that completed assignment and send it to the corresponding Dropbox. A second advantage will be the Dropbox for each assignment will be open for 2 class period days rather than having the assignment due the next class period. Any assignment turned in after that second class period day would have met and counted as late category. And a final advantage you will have with this medium is that you don't have to watch it during the scheduled time of class. This is certainly a big advantage for those living in the Pacific time zone. Otherwise, some would have to listen to this video at a fairly early hour in the morning. Each day the class would have met, you will be sent a URL address which will connect you to a link from a cloud where you can access the video. We are told this method reduces the chances of overloading our bandwidth, causing a crash or a freeze. You will need to stay fairly current as the link will not be open indefinitely. Anticipate no more than 1 week past the scheduled time of that lecture, so please do not procrastinate as the availability of the link will run out eventually. It is important to realize that college is still in session even though we have given more freedom to you when exactly you do that college work. Stay current as best you can. We will cross the testing procedure at a later date. So here we go now for our lesson. We're going to be finishing up section 6.5, and I'll be assigning that 6.5 here today. It'll be, Dropbox will be open. The Dropbox will be open through Friday of this week, Friday the 27th. In section 6.5, we've already covered direct variation. If you remember with direct variation, it was always k times whatever variable was varying directly. For example, y varying directly with x meant y equals k times x. If y varied jointly with x squared, it was k times x squared. Directly with z cubed, k times z cubed. Directly or jointly with both x and y, k times both x and y. Y varying directly as b and c squared, k times b and times c squared. K being our constant of variation, k staying the same throughout each particular problem. That was direct, and we did a bunch of problems on that. Today, to finish up, we're going to be looking at indirect variation instead of direct. Ways that they will say it would be y varies indirectly with something, or y varies inversely with something. For example, y varying indirectly as x, rather than k times x like we had previously, because it's indirectly, it will be k divided by x. In similar manner, if y varies inversely as x squared, it would be k divided by x squared. If y varies indirectly as z cubed, it would be k divided by z cubed. Y varies inversely as x and z would be k divided by x and z. Y varying indirectly as b and c squared, k divided by b and c squared. Notice all of these are indirect. All of them are k divided by something. That was opposed or opposite of what we had last time we met. Direct, they were all k times something. It's important to keep those two straight. Let's take an example. Here we're told that it is an indirect variation of y and x. Y varies inversely with x. We're given a multiple set of coordinates to figure out what our k value is. But again, because it said indirect or inversely, it is k divided by x. So here's my first set of ordered pairs. X is 4, y is 1. So the x becomes a 4, the y becomes a 1. When I cross multiply, I end up with k having to be 4. My second set will give me the same values. Both coordinates happen to be 2. So the x and y both have 2 substituted in. When you cross multiply, k will be 4 again, just like it was over here. Should be true for all of these. So if x is 16, the x here is a 16, and the y is a 1/4. When I cross multiply, 4k equals 16, k becomes 4 again. And I could try the last set of coordinates, but k would be 4 again. K was 4 in all of these. Therefore, my constant of variation is 4. To write an equation for this particular problem, I would take this k out, and I'm going to put 4 in. So my answer to that equation is y equals 4 over x. Then if we're asked, what would y be if x were 12? I keep the 4 in there. That stays constant throughout this problem. But my x value turns into a 12, which means my y would be 1/3. Now I would like you to try one. So I'm going to give you some time to try this and see if it makes sense to you. You're given that it's an indirect variation of y varying inversely with x. Here are the multiple set of coordinates. Find k, first of all. I'll give you about 50, 60 seconds for that. I'm not sure how far you are, but in all cases, you would start with that normal indirect variation formula, y is equal to k over x. Then you'd begin by plugging in the ordered pairs, in this case 4 and -5, the x being 4, the y being a -5, and you would substitute those in. Here you would substitute x to be a -2 and the y to be a 10. Here you would substitute x to be a 10, y to be a -2, and finally x could be 1, y would be a -20. When you cross multiply in all those cases, you get the same value for k. K turns out to be a negative 20. So if you were be asked to write an equation for this problem, because it's indirect, you're following this main formula. It's just now that you know that k is a negative 20 can be put right in there. So the answer to that question would be y equals a negative 20 over x. Now I can use that particular formula for any additional part of this problem that I want to work out. For example, what would y be if x were 40? I'm going to take the 40 and put it in place of the x in there. So if I do that, I have a negative 20 over 40, which is a negative 1/2. Again, hopefully pretty straightforward for you. Our next example. We're told this time y varies inversely as x squared. What's different here is the fact that this one is squared, not just x by itself like the previous problems. We would like to first find the constant of variation, or find k. So my formula, because it's inversely, is going to be k divided by, but not just x this time, rather x squared. So what I'll have is the following. Y is equal to k divided by x squared. Then we're told the y is a 10 when the x is a 2. So I have k over here's the key now, 2 squared, or 4. So 10 would equal k over 4. Technically it's 10 over 1, so when I cross multiply, k times 1 will give me 40. So they asked us to find k. I have done that. K is 40. That also means that I could get the equation for this particular variation by putting these two equations together. Here's the general one with k, but now I'm going to take the k out and put 40 in its place. So I have y is equal to 40 over x squared. That's the equation that's represented in this problem. Consequently now, if I want to find y when x is 8, I'm going to put 8 in there and square it. So I'm going to end up with 40 over 8 squared, or 40 over 64. We could reduce that down to make it 10 over 16. I believe we could also reduce it down to 5/8. 5/8 being our final answer. Again, hopefully fairly straightforward. We'll take another example now. This time we're told y varies inversely or indirectly as x squared, but now it's directly as z. Remember, directly was k times. Indirectly or inversely is k divided by. So our general equation would be k, when it's inversely, it's divided by. Inversely, as x squared would be divided by x squared. And then directly as z would mean times z. So I have this general equation. It's crucial that you can get from this first line to this general equation. Then all we have to do now is find the variable k. So to that end, I'm going to take the y value and plug it in. The z value happened to be 10. The x, which needs to be squared, was 5. So I would have 4 is equal to, this would be 10/25. I can cross multiply here. 10k times 1, 4 times 25. K turns out to be, in this case, 10. I can now plug that into this general one. So instead of the k, I'm going to put the value of k in there. So I end up with y to be 10 times z all over x squared. That's the equation that fits this particular problem. So now if I want to find y when z is 8 and x is 4, I'm going to be substituting those values in. So instead of the z, I'm going to have an 8. The x is a 4, but it needs to be squared. So this will be 80 over 16, turning out to be 5. And that would be my y value at that point. This one was a little tougher because we had an inverse variation along with a direct. That meant that we had k divided by something as well as k times something. And again, getting from that first line to this general equation is a key step in these variation problems. I would like you to try this one on your own. I'm going to give you a head start, and then I'm going to fill in behind you. So go ahead and try this one on your own. And hopefully you got a k value to be 24, and you got your y value to be 2.4. Let's try another one once. This is more of a word problem. Again, anticipate this type of problem on the next exam, where we would give you not only the equation itself, but we give it to you more in a word problem. So let's read through this one together. The resistance of a wire varies directly as its length. So that's the first part. Resistance varies directly as the length. So I'm going to write in here at that point, K I apologize, start over. Put in my resistance for R. When it varies directly, it will be K times directly as its length. So I'm going to go L for length, K times L. But now it's inversely as the square of the diameter. Inversely means K divided by the diameter squared. Super important that you can get from that first sentence down to this general equation. Again, just a quick review of that. Varies directly as the length would be K times the length. Inversely, as the square of the diameter would be K divided by the square of the diameter. So now we're going to find K like we've been doing. If the resistance of the 640 feet, 14-inch wire diameter is 16 ohms, so the resistance is 16. So R here turns out to be 16. I don't know K yet. The length in this particular case is the 640 feet. And the diameter was a 14-inch. That 14 needs to be squared. So I need to take the 14 and square it. That will give me 16 equal to 640K. 14 squared is 196. So now I could cross multiply and divide by 640. So K will be 16 times 196 divided by 640. K would then turn out to be 4.9 in this case. So I now put these two together. And my equation now becomes R equals, instead of the K, I'm going to put 4.9 times L divided by the diameter squared. We want to find the resistance, because that's what they're asking me to do. Find the resistance, so I'm looking for R. The length is 320 this time. And the diameter is 21 inches. Don't forget to square the diameter. That's an easy place to make an error. So when you calculate this all out, you end up getting 3.5 repeating. In this case, our label comes like it is up here, ohms. So that would become my answer. All right? I would like you to try this third one on your own. I'll give you a head start again. See how you fare. One of the things that's a little bit confusing with this one is I have an illumination variable, but I also have an intensity variable. Describing one with I could be confusing which one we're talking about. Consequently, I'm going to go with illumination, abbreviated that way. Varies directly would be K times the intensity, which I'm going to abbreviate INT. And inversely as the square of the distance, d squared. It is possible you have different variables in here, and that's fine, as long as you keep the intensity and the illumination straight. So in the values given, the illumination is 50. My distance is 2 feet. That distance had to be squared. The intensity was 400. That would go in for my intensity, 400. So 50 would equal 400K divided by 4. If I cross multiply, it's 400K times 1, 50 times 4. It's 200 over 400. K will be 0.5. I can put that now back into my equation. So the illumination, instead of the K, I'm going to put in the value 0.5 times the intensity divided by the distance squared. They're asking me to find what is the illumination. So that's the part that I don't know. I know my K remains constant throughout the problem. My intensity is 3840. And my distance was 4 feet. When you multiply all of those out, turns out your illumination is equal to 120. And my label, similar to what it is up here, is candle power per square foot. And that would be my answer. That completes our lesson for the day. Hopefully I'll get better at using this medium, and hopefully you're able to make this first one happen. I want to remind you again, I'm assigning 6.5. It's assigned here on Monday, the 23rd. It'll be due on Friday, the 27th. All right, have a good rest of your day.